y'all. All right, y'all. I'm gonna get this thing started. All right. Thank you so much, everybody, for coming out online. Thank you so much for coming out. We got quite a few people online already. That's a great sign. In person, if you can't see the room, but it's pretty packed right now. But for those that don't know, this is a Dallas software developer meetup. Thank you so much for being here. You could be anywhere else in the city right now, but you decided to be here with us, and I appreciate that. Couple things, couple housekeeping. Number one, gotta thank the people that make this happen for us. Our amazing admin team that dedicate their time. We've got Dennis over there who's dedicated his time to be here tonight. Big up for Dennis, please. Then we have Dennis squared in the back over there, our second Dennis. We have Clint, who can't be here tonight, unfortunately. Clint, it's actually his kid's first day of school and meet the teacher tonight. So Clint and Melissa both are not here tonight, unfortunately. And of course, Eric, our thoughts were with Eric. He's not here tonight, but we're keeping him in our thoughts. Nothing's wrong with him. He's okay, but he's just not here. So make sure we think about him. And of course, myself, I try to do what I can when I can. For those that don't know, I'm Danny Thompson. I am the director of technology at a company called this.labs. Big up to our sponsors tonight. Number one, huge thank you to Yum Brands. They own the building. They're the reason why we're able to meet here. They donate the space to us all the time. No matter the ask, how big or small, they kind of give it to us. So big thank you to Yum Brands, please. Make sure they can hear that. Outside of that, second sponsor, please big up to AppRite. AppRite, no matter how big, how small, or how over budget we often go, they never stop the pizza for us. So big thank you to AppRite. They're the reason why I got pizza. I've made them angry a few times, I already know. I've gone over budget more than a few times, but they let it go. So until they cut it off. And last, big thank you, this.labs. They're the reason why I was able to come tonight. And to be honest, they're going to be a bigger sponsor going on forward for a lot more events. We got like some swag and some other stuff coming on as well. For those that I just started this.labs recently. It is a tech consultancy company that has worked with some of the biggest players around. Honestly, they've done some amazing stuff. So highly recommend, if you work in an enterprise level organization, need some help, maybe we can help out. But don't feel pressure about that. And they're very big on the community. They do a lot with the community. We got some very big things planned, so I'm kind of excited about those. Some of y'all know I've talked to a couple people about some of the ideas that I've got, and they've kind of been empowering me to do that. Night of JavaScript. The purpose of a night of, it's our theme. We do a night of. And the idea for this is to do a tech conference for the community without any barrier or cost of entry. I know for a lot of people, honestly, where the idea came from, people were saying, I can't afford to go to XYZ conference, even though it's an hour away, 2 hours away. And so if income or location was the barrier for that entry, we wanted to tear that down. So we give you a mini tech conference. The way this kind of works out is tonight we have 5 amazing speakers. I'm in that amazingness, I know. And the 5 that we have, they have all agreed to donate their time and give a talk. No pressure. We try to get amazing speakers. I feel like we have a star-studded event tonight, but one of the coolest things about this is we have a range of experiences from director and ML architect and founder to they've just had their first job in tech recently and they're sharing something that they've recently learned as well. So we try to open the door for anybody really. If you've got something valuable to share, we try to help you out, work on it if you need it, but we bring it around. And the biggest thing of all, of course, is there's no cost to this. There never will be for anything that we do. If we're doing some kind of event and there's a paid fee, it has to be for charity. There's no way that we'd ever charge for anything that we do. So a couple of things on the speakers in particular. We got Jacob here, principal consultant, Focus Dev Solutions. He's going to be speaking tonight. We got Patrick in the back from Netflix. He's a machine learning architect. He's going to be speaking tonight. We got Trey Clark, software engineer from University of North Texas. He's going to be speaking tonight. Andrew Smit, technology associate. Very excited about that one. First talk, he's going to be giving one tonight. And of course, that $1 million smile will be giving a talk tonight as well. One thing I want to address, the last meetup we did, I kind of hit on this one a little bit, but I got a lot of questions about this one. And one thing I really want to emphasize, we don't always plan out our meetups far in advance. We try to do 2 meetups a month, every 2 weeks. Our next meetup, I haven't even told the other admins what the next meetup is going to be yet. Next meetup, we're going to do how to get a job in tech meetup again. We haven't done that for a year. It's always a big crowd pleaser. So prepare for that in 2 weeks. We're going to throw that down. I have no clue who the speakers are going to be, no clue who the panel is going to be. Just know that they're going to be amazing, and it's going to be a valuable night if you're trying to get your first job or trying to get a job in this current market. I was kind of talking to Patrick in the back. When I took this position now at this dot, I had 4 offers at the exact same time, and I was trying to mull them over. And so I'm going to go over quite a few strategies that kind of make those opportunities happen. So hopefully that'll be a lot of value for those that need it. One thing I want to point out in particular, mainly because I was having this conversation with somebody in one of my Discords, and he was kind of talking about how he's applied to these hundreds of job opportunities. And it's kind of, if you remember last meetup, we kind of talked about this as well, but he applied to hundreds of jobs, doesn't get a reply. This dot, we posted 10 job openings, right? Literally, we didn't post it on a job board. I tweeted it, posted it on LinkedIn. That was it. We had 900 applications by the end of the day, right? 900. Of that 900, maybe 1% were worth having a conversation with. I don't even say that lightly. These weren't junior opportunities. This wasn't mid-level opportunities. It was senior lead engineering manager opportunities. And there was nothing, like, if I wanted to talk to this person, there was nothing on that resume, nothing on that LinkedIn that said I should have a conversation with this person. A lot of developers are used to the marketplace pre-pandemic, especially if you're a developer with multiple years of experience, where you didn't necessarily have to advocate for your skill set. You had, if you made a cough and it sounded like the word JavaScript, you found yourself in a job interview. That's not 2024 anymore. And so for a lot of y'all, you're missing that. You're missing the mark on giving them an incentive and a reason to have a conversation with you. Please don't get so discouraged to the point where literally one person saying, I'm giving up tech to go work in another industry because it's just not working out for me. I know there's a lot of people that go through that. I can tell you from firsthand experience, and I can tell you most of the senior developers in here probably felt the exact same way when they're trying to get the first job in tech. They never walked into an interview and they're like, hi, and they're like, you're perfect. I gotta have you on my team right now. Even with the best connections in the world, you're advocating for your skill set. Give yourself a fighting chance, but please don't get so discouraged. This market is tough. I'm not gonna lie, it's not easy, but just because you know it's hard, just do it hard, right? Give yourself an actual fighting chance. If you're at a meetup, have organic conversations, talk to people, make those connections, add them on your network, LinkedIn, Twitter, eHarmony, whatever it may be. Add them on there and get connected and start having those conversations. You never know where one conversation will take you. Trust me when I say this, you absolutely got this. Put yourself forward, have those connections. All right, with that being said, hopefully that helped the one person that I'm really directing this to, but hopefully it helped others too. I'm gonna bring up the first speaker tonight, Trey. Trey, come on up.
Hello, hello, good evening, everyone. So what are we going to be talking about today? So what is testing? Why should you test your code? Sort of like the testing iceberg, the hierarchy of the different types of testing. We're going to talk about just, again, a little bit of foreshadowing. We're going to see some small code snippets of tests that are actually written. And then I'm going to sort of give you all a little bit of a learning module that you can take home if you like to practice a little bit more with your tests. So what is testing? Here's a long, complicated definition. Thank you, ChatGPT, for generating this. But it could all be really boiled down to verification that your code actually does what you expect it to do. I wrote this function that's supposed to, I don't know, clean up the ecosystem. Well, I need to test to see if it works before I deploy it and, you know, take down the entire infrastructure of the world. That's okay. So what we're going to do today is we're going to learn some steps that we can do so we can start testing our code to make sure that we get the expectations and the values that we are expecting it to do. So why is testing important? Great question. So really the big 3 things that I could boil this down to, that it really helps with your code quality, it helps with maintainability and efficiency of your code. Code quality, if we're regularly testing, the code's not going to break if all the tests pass, which is good. So by identifying those bugs and those issues early in the development process, we can then detect those bugs and help stop them from reaching production. Maintainability, again, if we're testing often, we're able to provide that up-to-date documentation of what works, what doesn't work, and we're able to keep those dependency versions up to date. And lastly, with efficiency, this all sort of goes hand in hand. It streamlines the development process, gives you faster feedback on what works and what doesn't work, so you can go in and fix it quickly. Now, there's 2 types, a sort of like hierarchy of tests. You have manual testing, And then you have automated testing. We're going to stick with more of the automated testing, which I would recommend if you are working with a team. Manual testing may work for smaller things that you're working on individually, but what we're going to talk about today is automated testing. So under that, there are two types of testing: functional and non-functional. Non-functional really refers to like the things that necessarily you didn't write. So we're thinking about stress testing, how many people can be on my server, how many requests can I keep up with, security, things like that. And then we have functional testing. These are the things that you write that you're trying to detect a one-to-one value of. So unit testing, interface testing, smoke testing, so on and so forth. What we're going to talk about today specifically is functional testing, and more specifically, unit testing. So I drew this in Microsoft Paint today. So this is the testing iceberg. So it starts at the very top with unit testing. So we're testing individual functions in our code. Does this thing work? I have a function that's supposed to return x plus y. Does it return x plus y? Under that, we get to integration testing. So if I'm supposed to get some sort of information from some server that lives off elsewhere, am I able to do that? And am I able to do whatever I'm supposed to do with that information? And then lastly, we have UI, or maybe we call it end-to-end testing, which is basically I have a user and I have a user story. Am I able to fulfill that user story from the beginning to the end? The user enters my website, they go here, they click this link, this button pops up, bada bing, bada boom, they've done the thing. And that is sort of like the end, the quote unquote end of the testing sort of like iceberg here. And so again, we're going to just talk about the very top, which is unit testing. So JavaScript offers a lot of tools for testing. A lot of these probably seem familiar with you if you indulge yourself in testing. Some of these have pros that help help the other frameworks, sort of like Shine. Some of them are really good with unit testing. Some of them are really good with end-to-end testing. For those that aren't really good with end-to-end testing, we can combine these frameworks to create a nice sort of like testing spaghetti, if you will, to actually get some good information. So the one that we're really going to be focusing on today is Jest. So then what is Jest? Jest is a testing framework that's developed and maintained by Facebook. It was developed or released in 2014. Some of the things that it boasts is zero configuration to start. So install the dependencies, make the testing files, you're good to go. Has a built-in test runner, so you don't have to download any sort of external programs or anything to run the test. You just do it right in your terminal. Some of the things that Jest is able to test for, being developed by Facebook, of course, one of the things that it should be good at is detecting and testing for React components, right? So it integrates really well with React testing. It tests your dependencies, individual functions, asynchronous code. And one of the things that we don't think about as much is errors. Does the code that I write give me the errors that I needed to in each particular case? So in a nutshell, that is Jest. And that's what we're going to be talking about today. So we're going to look at some examples of what Jest is. And the way this is going to work is we're going to learn a couple of things in terms of like the syntax, some of the built-in functions that Jest has, and we're going to see a code snippet that shows those things. So the first one here, let's talk about the format of a Jest test. So some of the things that you can look for in a test is obviously we have to have a name. So this thing describes what the test is doing. I expect this to do this, or this should test for this, right? Pretty like human readable thing. What is this test supposed to do? And then we have a callback. So what is the test? Like, what is the functionality? What is supposed to run once this test actually does or runs? Inside, this is more of an optional, we can have a setup. So any states that really need to be present for when the test is actually running. Do I need to create some objects? Do I need to do this, that, so on and so forth? And then lastly, we have our assertion. So our assertion is basically the meat and bones of this. What is expected for my test after it's finished? I expect this function to produce this value, so on and so forth. Now that expected, that assertion, we're going to dig into that just a little bit more before we get into the code snippets. So the function expect takes in a value. It could be a primitive value, it could be an object, it could be a function, whatever you want it to be essentially. And what this does, it compares values to, or just compares values. Inside of this, you could have a modifier or a matcher, which we're going to talk about here in a second. And so we see here the little code snippet. Right here, we have this function called test. test takes in 2 arguments. It takes in the name of the test. So we see this describes the test. And then it takes in the callback function. Here we see we have an anonymous function, and all it's doing is just checking for some things. So after this test run, I expect that some function that I call and I pass in value to test dot matcher. So I'm chaining this matcher built-in function to be whatever the value is that I'm trying to look for. And then another example here. So we expect some other function to, and then we have what's called a modifier, which we'll also talk about, to match this value that's going to be checked. So we can have multiple assertions inside of one individual test. And this is sort of the breakdown of what it looks like. Now, the matchers themselves, that's really what's going to make this assertion work. And so what this does is lets you test your values in multiple different ways. So do I want to test 1 to 1, or do I want to make sure 1 is greater than 0 or something like that? And so what we can do is we can use just matcher by itself, or we can use a modifier, which is going to obviously change how that test is going to work. The 3 that we have are not, which is just the opposite of. We have resolves, which unwraps a resolved promise to get some values. And then we have rejects, which unwraps a rejected promise to get some values. And then some of the common ones, I'm not going to go through and read all of them because that's just a lot. But we can test for strict equality, values of an object, truthiness, number of values, comparing strings with regular expression, and the list goes on and on. There's so many choices, but they all can do many different things. And so what we're going to do is we're going to use these matchers to check for values. So our first example here, very simple. In the top left, you see up there, we just have a function, return x plus y. So we're going back to that add function. And so what I want to test for is, does this do the thing that I want it to do? And so down here, I have my test. Down here, I have my test. That what I'm doing is I'm just adding 2 numbers. And so we have our callback function here, and I expect my add function that I wrote when I pass in 1 and 2 to be 3. So the return value of this just should be 3. So once I run that, I should get a pass. We've got it. And so this is an example of using a matcher with that expect function to compare those 2 values. So if you've ever wondered how do we write a test or been scared to write a test, this is it. Congratulations. Cool. Now let's dive a little bit deeper. So what we didn't see before was a setup. There wasn't really any setup to it. It was just a function call, did this function do the thing that I wanted to do? And so what we can do is set up some sort of state that we can use to call or help with our tests. So that's a call to a database. That is object creation. Do we need some sort of like regression or progression of a state through its lifespan for it to actually do what we need it to do? So we can have that happen before the assertion. Also, I just want to throw in here, we can have a sort of like a test wrapper. And that's the describe method. And this is what creates a test suite. So we can group like tests together so they're not, or for better organization, essentially. So let's see an example of this. So on the left side here, we see we have a class called card, and it has a name property, HP, attack, and in play. And we have 3 methods. We have attack, check, and play, and we have a 2-string method. And so what I want to do is I just want to make sure that all of these things work. Now, this can be as minimum as 3 tests, but it could be like as many tests as you want it to be. And so then on my right side here, I see this wrapper, this upper wrapper, which is going to say describe. So I'm describing all of the tests that are inside of this test suite. And so this test, cards creation and card battle. It takes its second argument, which is an anonymous function, and we see our first test here. So card 1 has 100 HP and 30 attack. That's what I expect to happen. And so I'm creating a new card. The name is APA, 100 HP, 30 attack. And so I just chose here to sort of test 2 things with one test. And so if I do a 2-string on that card, I expect that to be this output. That would show me 1, that the 2-string does what it's supposed to, and 2, the value of my object is being populated as it needs to be. Okay. Second one here, card 1 attacks card 2. So our setup here is we're taking two variables. So card 1, the return of APA. Card 2, we have a new person, beats person, 50 HP, 20 attack. So card 1 attacks card 2. So now I expect card 2's HP to be this value of 20. Okay, so a little bit more setup. Now, this last one here, a couple more. So now we're taking turns back and forth. So return of Appa, return of pizza person, they're going back and forth. And then now I can use those methods again. So I want to check to see if my attack function actually changes my in-place state. And so back and forth. At this point, card 2 should have 0 HP. So then that check and play should be false. But you can also check to be truthy. So this is one of those things where, like, I guess preference on which matcher you use, but they kind of do the same thing. That could be to be falsy, to be truthy, or to be true, or to be false. They all do the same thing, personal preference. Cool. Lastly, we're going to talk about our mocks. One of the things that we didn't see in those past tests is calls or any sort of calls to a database, grabbing information from some external source. Now, that's good for production. When we're testing, one of the things we want to avoid doing is too many calls to some sort of external source. And the reason because of that is because there could be some sort of problem happening on our end. There could be some problem happening on the receiving end, right? It could be some sort of like server load. The servers could be down, so on and so forth. And what we want to do is we want to make sure that our test can still run despite any sort of interference not on our part. So what we can use is a mock. Now, what a mock does is essentially spies on some sort of function that's happening, and it can replace the behavior of it and even give it a return value or force it to return something else. We see here just the definite or sort of like how it's structured in the directory. It has its own sort of directory, and we can have the mocks built into that. So typically these are used with asynchronous functions, again, so we don't have to call a database, but we can sort of simulate those returns if the database were working like we needed to. So let's look at an example. So a couple of things on here. I know that one's pretty small, but I'll try to walk through it. So up here, on the left side here, we have sort of our mock. And so our database, we're not actually going to query a database again, because that could take a long time, especially if we're running a lot of tests. So I'm actually creating a sort of like local database, 2 users, John Doe and Jane Doe. Cool. What I'm exporting here are 3 different functions: find, all, and update. So this is assuming I'm using some sort of object relational mapping database like SQLize or something, and it has these methods available to it. And so basically what's going to happen is whenever I'm testing and my API calls these methods here, he's saying methods, functions, yeah, it calls this function, it's going to replace the behavior of that function. And then I can give it some sort of return value, so I don't have to query some database that lives elsewhere. And so we can have all our testing done locally in our own little container. And so in the middle here, we see just a very rough sort of like Express.js API. The first route is just index or just our home route, says hello world. Second one, what it's supposed to do, it's supposed to find a user given their ID and return that. If not, we return a 404. Second one is the same idea, except we're going to update a user. If we can't find that user, it's 404. And the last one, we're just supposed to grab all of the users. Now, this sort of like string of code for this API could, again, have 4 tests. It could have 20 tests. But for this particular case, we're just going to limit it to a couple. And so what we can do first to set up this mocking environment is the very top, just stop mock. So what this is going to do, it's going to allow all of my mocks to be available in this scope here, and so that I can use those. And so here we see that the scribe come back, so we have our test suite. And then here we see something new, before each. So what this does is going to essentially set up or to have some sort of modification to our mock. Because our tests are going to be manipulating this database, either adding something to it, taking away, updating, so on and so forth. So we want to make sure that each of our tests are able to start from essentially a neutral ground. And so before each of my tests, I just want to reset all the mocks back to their neutral zone. I can do this before all, I can do this after all, I can do this before each, after each. But depending on what I need, I can update the mocks accordingly. And so getting in the test here, I want to test that this route right here should return a user. And so I have the user, what I'm expecting to get returned. And then I'm setting that find function that we defined over here to return this user. And so when I query the database just a couple lines down, so I'm getting whatever information's at this endpoint, I'm not actually going to query a database. It's just going to look for this method. It's going to run this logic, and it's going to output this. And so we don't have to query any sort of external internal database, it's all locally scoped. And then I expect my response status to be 200 because I got the information. And then I also expect it to equal the user that I put up here. Next, we see the same thing. So we should return a 404 if the user is not found. So I'm setting that return value of that mock to be null. So if it's null, we see here, we're going to return that 404. So I expect it to be 404, the return status, and then the text to equal the user not found because we didn't find a user. And the last ones, same thing. So we have a user that we're going to essentially expect to be back or come back. And then we have an updated user. We run the find method here. We give it a return value. We have update. We give it a return value, run the query, and then we have our expected results at the end. And so again, mocks are really good if we have a whole bunch of different database calls or asynchronous calls that we need to do, but we don't necessarily want to actually query the database, but we want to keep it all localized. So with that information, I'm not necessarily going to give you homework, but I will give you a resource that you can use if you would like to either start writing tests or develop your test writing skills a little bit. So if you go to this, you don't have to now, but this QR code takes you to a GitHub repo. And in this GitHub repo, there are 3 examples that I've written, and essentially sort of like mocking what we just looked at here. And so you get some tests, and you have to write the code to the test. Or you get some code, and you have to write tests for the code. And so it's going to go over just in general. So you're looking at the syntax, making sure you're configuring it correctly in terms of writing the test. How do we test asynchronous functions using mocks? A little bit with Express.js, so like a little bit of API writing, and then just general algorithm writing, something that's super important, especially as you go throughout your career. If you'd like to contribute to the project, that's cool as well. If you want some of that open source candy, if not, that's cool too. I just want to have this up, and I'll just keep this around for whatever. But again, my name is Trey Clark, software engineer at the University of North Texas, and I appreciate you all listening today.
For 1 second. All right. So I'm gonna bring up our next speaker now. Jacob. That's some fun, right?
Sorry, this is bad. Thank you.
Hi there, everybody. My name is Jacob Orshalick, and today I'm going to be talking to you about generative AI. So I wrote an ebook recently on generative AI and using it with JavaScript. All right, so if you go to this link, this GitHub link, and sorry, I don't have the fancy QR codes like he did, but if you go to that link, you'll see that I've got an ebook there available for you. And what I'm going to talk about today is the first couple of parts in this ebook. And I'm trying to get through it as quickly as I can. You know, I've only got 15 minutes here, but I'm going to try to code and put together a service that communicates with OpenAI's APIs in the amount of time that we have. So if you haven't heard of generative AI, just think ChatGPT, right? I'm sure everybody in here has at least had some interaction with ChatGPT at this point. And most likely you're using it on a day-to-day basis. You know I do. I go in there, I check my code. You know, I've especially enjoyed GPT 4.0. The most recent release has been great for coding. So if you're not using it, get in there and try it out. It's really, really valuable. Now, there's a lot of truth to this. And when you think about a lot of the AI startups that are out there today, they're really not the ones creating the models. Most of them are actually using the models that exist out there, and the big companies are the ones generating the most powerful models. Whenever you think about trillions of data inputs for creating an LLM, a large language model, there's a lot of computing power and expense associated with that, and a lot of data scientists working towards that. So it's really hard for small companies to try to build these massive models. So when you have companies like Facebook that are releasing these open source models, take advantage of it, right? And that's what I tell all my clients. You know, I'm a consultant. You know, I work for myself, and I've been doing it for about 15 years. And what I tell everybody is that this feels a lot like whenever open source started, right? You have all these models that are coming out, being released and available for use. Take advantage of it. Don't build things yourself. You know, see if you can do the things you want to be able to do with AI with the models that exist and that have already been created and released for you. There's a lot of value there that you can already take advantage of just by either fine tuning or tying your data into those AI models that are already there. So today we're going to talk about how you can call an OpenAI model. I'm actually going to show it through a coding example as we, walk through this presentation. But GPT models are LLMs. And the LLMs are just basically large language models. And that's what powers ChatGPT. So anytime you interact with ChatGPT, it's basically sending a prompt back to one of their APIs. If you've never used it before, use their APIs behind the scenes. And then it responds back with some type of completion. And the way it works is that an LLM is just trying to guess tokens. So when you send in a prompt and you send it in some kind of question, or maybe you're taking text from a document and you want to summarize it, it takes all of that information, passes it through the input, and then receives completions in the form of tokens. And it just kind of guesses each token based on the prompt and based on what it's output so far. So it's over and over again running an algorithm to kind of guess what's coming next and try to build out that response that you end up seeing in your response in ChatGPT. So what we want to do today, and what I want to show you guys, is how to use Node and build a REST service on top of Node that can actually call into these APIs and get back one of those completion responses. And we're going to use GPT-3.5 Turbo for that, which is kind of the basic model that you can use that's the least expensive if you want to get in there and try these APIs out yourself. All right, so these are the technologies we're going to take advantage of. We've got Node, we've got Express on top of Node. Express allows us to build kind of a GET request for a REST API that allows us to call in to a service. And then we've got LangChain, which LangChain allows you to put together a chain of calls to an LLM. And this becomes really valuable when you start using this to build something useful. So what we're going to use it for is something very basic. We're just going to call into OpenAI and use those APIs directly to get back a basic response. But you can really start chaining together things to use your own data, to use information that you might retrieve from the web or whatever in order to increase the capabilities of those calls and those prompts that you're making out to those APIs. All right, so the first step to get this going is you have to install Node. And like I said, I'm going to try to code as we go. So let's do this. Let's just double check real quick that I've got Node set up. And I do. Let me get this out of the way. All right, so everything's good there. So that'll be your first step. Now, once you've verified that you have Node running, then we'll have to actually initialize the project. So we'll run an npm init-y. That should create a project locally. Boom. I'm going to go ahead and open this up in VS Code. And what you'll see here is that inside of this, I now have a package.json. All right. And this package.json is what is created for any basic Node project. So anytime you start up a Node project, this is necessary in order to define the Node modules that you need, the dependencies that your project might have. So if you use any type of open source, it's all brought in through this. So I'm about to install a bunch of modules in order to make our application run. All right, so let's go ahead and take a look at that. Next step. So now I'm going to install the Node modules that we need. Now, like I said before, we're going to use Express. Express makes server creation quick and easy. So you can define using Express those GET requests or POST requests or anything that you've used before if you've created REST APIs. It makes it super simple to do that, as you'll see. We're also going to use LangChain. This is the framework I was talking about before that makes it super easy to work with and communicate with LLMs and kind of build on top of them. And then we're also going to use the plugin for LangChain OpenAI. Now, this provides the OpenAI integrations, but there's integrations for a lot of the models that you've heard about out there. So regardless of whether you're using OpenAI, using Llama, whatever it is, there's probably an integration with LangChain that you can install in order to communicate directly with that particular model that you want to be able to use. All right, so in my command terminal, what I'm going to run now is the install for all of these modules. And this is going to take a moment. So while that's running, the next step is going to be creating a server file. So once we get down all those modules, we have everything we need in order to put the pieces together and put all those modules together to actually communicate out with OpenAI and execute a prompt in order to get a response. So let's take a look. It's still executing. So while that's doing it, I'm going to go ahead and open up my text editor. And you'll see inside of VS Code now, I have a new file, server.mjs. I'm going to go ahead and copy that code in that we saw there into that new server.mjs file. Boom. So what this is doing is first it's pulling in the modules that we just installed. So we're pulling in Express, we're pulling in LangChain OpenAI, which is that integration I talked about. We're pulling in cores, and this is just for the purpose of being able to make requests from a browser. So don't worry about that too much. But we initialize Express. We start our chat model here, which is chat OpenAI, because obviously we're to be communicating with that. And then we create a get API. All right. And we want to call on that chat model and send a prompt. So my prompt in this case is going to be to tell me about the Beatles in under 500 words. All right. So let me try that out. And you can see that it's printing out what I see here, which is server is running on port 3000. The reason for this is because I told my app, the Express app, to go ahead and listen on that port 3000. Perfect. So it's up and running. We're ready to go. Now, the question is I haven't done anything else to communicate with, to say that I'm communicating with OpenAI, right? There's usually some kind of API key you have to have or something like that. Well, that is true. So in the next slide, what I talk about here is that you have to register on platform OpenAI to get an API key. And once you do, and you set it up and you have your API key, you'll store it off, and then you'll eventually drop it into a variable, right? So you'll need this locally. And the great thing about the OpenAI plugin for LangChain is it will actually look for this environment variable for your OpenAI API key if you have this exported, whether using Windows or Mac. This is actually the way to do it in the Mac. But if you have this variable set up with your key that you set up in the OpenAI window, then it will go ahead and pick that up and you're ready to communicate with OpenAI APIs. All right. So let's see if that worked. So I started up my server. You see it's running on port 3000. So I'm going to go ahead and open up my browser. And here I'm going to call this. And I'm going to wait a little while it's generating all of these tokens, right? Okay, great. So here it is. Here's the response. You can see it gave me back a good response to the prompt that I sent in, which was describe the Beatles in less than 500 words. All right, talks about how cool of a band they were, everything they did, how popular they were at the time, and how they changed music forever, right? So with that, you can actually make this better for your users, all right? So what we want to do is stream these LLM responses. And if you use ChatGPT, you're probably familiar with this. You've seen the little cursor that flashes whenever you ask it something, and it slowly starts printing out the response. Depends on which model you're using to how fast it will actually respond. But you get kind of a sense of it performing pretty well because of the fact that it's, quickly printing out that information to the screen. If you had to wait, like just what just happened, where I'm sitting there hoping that it's going to give me a response and waiting for that response to happen and not getting any feedback, you might get pretty frustrated with ChatGPT, especially if it's generating a really long response, right? So instead, what we can do is use streaming. And streaming allows you to get chunks back as they're generated by the LLM. So when you send that prompt in, like I said, it's going to guess what each token is as it goes. So it guesses the first one, then the next one, then the next one, based on all the information it has. So you want to be able to get that information as it's sending back those tokens and as it's generating them so that it feels like it's performing really fast. So how can we do that? We can use LangChain for that. It actually has a stream capability. And it's available for its LLMs, its parsers, its prompts, its retriever, its agents. It's built into the interface across the board. So no matter what piece of and what component you're using in LangChain, you can use this to quickly get better performance and get quicker responses out to your users as the LLM is doing something behind the scenes. All right. So let's try it out. Let's take this logic and let's go ahead and code it into the server MJS that I already created. So I'm just going to copy and paste this here. All right. And I'm going to go ahead and restart this server. And this time, when I make the request, you'll notice something a little different. See how it's printing out the information as I receive it? It's streaming back that response as the LLM is generating it. So I'm making a request out to the OpenAI API. I'm giving it the prompt, and as it's guessing those tokens, it's sending them back to me so that I can then send them back to whoever my caller is, right? We can make it feel like it's performing better to the users. The end users get a better performance out of that, all right? And they get their response quicker. And the other thing you can do is allow them to cancel this, right? So if they're getting the response and they realize, that's not a response that I really want, you can cancel it and stop spending money on the tokens that are being generated. Because I will tell you, all of these APIs that you use, they cost money and they charge you by the token. So every token you generate there's gonna be a bill at the end of the month that is associated with that. So just be aware of that and, make sure that you're getting the response that you want. All right. So that said, where do you go from here? Well, the next step I would take is looking into what's called RAG. Let me see if I can hide this again, sorry. And this is called Retrieval Augmented Generation. And what this is really, in a nutshell, it's using your own data with an LLM. So what you want to be able to do is take your app, and whenever you send a prompt in, make a request, and hold on just a moment, sorry. Oh, there it goes. When you send in a prompt, you want to create a call chain. And that call chain will call into a search index to get some data back. And then whenever you get those results back, you want to be able to send your prompt plus any search results back to the model so that it can then generate some type of completion with citations. And what that means is that you can use your data with the LLM to generate some kind of response. Now, if that doesn't make any sense to you, let's take a look at an example. So let's say you have a help desk employee, and the help desk employee works tickets and documents those tickets in some kind of knowledge base, right? They're sitting there on their daily work, and as they talk to people, they're basically documenting all the details of how they help them solve their problem, all right? So as they're doing that, they're documenting that into some kind of data store, right? Some database. And that you can create a search index around that database, okay? So that if somebody wants that information, they can go and find it, all right? So what you can do is create a help desk chat bot. And that chat bot, what it will do is when they send something in, they're looking for some type of information like, my machine is breaking, I don't know what to do, maybe I need to, or I'm having an issue with, Windows Explorer or something like that, right? They can type that into a prompt. It can then call in query a search index to see what's in that knowledge base, get back something from the knowledge base, and then we can send that to the LLM, the results from the knowledge base, so it can generate some personalized response based on what they actually asked in their prompt. So it uses the prompt and the data we retrieve from the database in order to generate some kind of useful information so it feels like they're actually talking to a person. And that's how a lot of these chatbots that you use today work, is they're using this RAG type approach where it's internal data being fed to an LLM along with what they're asking in order to generate some type of useful response, right? That's why it feels like you're talking to a human, all right? So if you want to find out how to do that, my book kind of walks you through, first of all, the steps that you just saw, and then takes you all the way to creating what I'm talking about there, which is essentially a chatbot that uses generative AI with your own data. So if you're interested in that, check out my ebook for more, and feel free to connect with me on LinkedIn as well.
Do that 1 second. All right, introducing the next speaker. Oh, Patrick.
Good job, man.
Oh, I got a countdown. 3, 2, 1. All right, we're about halfway through, everyone. Just do a quick little stretch. It's a long series of talks. Need to be nice and limber for what we got coming coming up next. We're gonna be talking about performance profiling React. A jam-packed talk, try and fit it all in 15 minutes. Answering the fundamental question, why is your application slow? Before that though, 20 seconds, why listen to what I have to say? You would be right to be a little suspicious because I no longer do front-end development as my day job day to day. I'm now an ML architect at Netflix, focusing more on AI use in Hollywood, but I used to do a lot of front-end development for over 10 years, and including some work on Chrome itself at Google, and working on the Chrome dev tools, which is part of what we're going to look at today, as well as Lighthouse. So hopefully still a little bit of slightly dated front-end wisdom to share with you. So what is that wisdom? Well, it's these two things right here. We're going to be walking through React lifecycle, just really basic. What is React actually doing when it's running your code? Enough to understand why it can be slow at times. And then we're going to do profiling 101, which is what tools are available, what are they telling you, and how can you actually use that information to improve your applications. React lifecycle, really basic terminology about what we're going to be doing. So number one, the DOM. What is the DOM? If you've been around web development at all, you've probably heard this. It stands for Document Object Model. What does that mean? Well, it's basically the interface that the browser gives you, the web developer, to create and manipulate your web page. When we talk about the DOM, usually what we're talking about is just the state of the page. What elements are on it? What does it look like? And how are we going to manipulate it in the future based on user interaction? If you've been around React for a while, you might have heard the term virtual DOM. So DOM is the actual DOM in the browser. A virtual DOM is someone else's DOM. It's not real, it's virtual. And this was popularized by React about 2013 or so. And it maintains a separate copy of the DOM. In other words, what do you want the page to look like? So the main takeaway that I want you to have is that virtual DOM moves you away from actually using browser APIs to manipulate the page. And instead, you're declaring what you would like the page to look like and leaving all of the actual DOM manipulation to someone else. In this case, a framework, mostly React. And if you don't know what any of that means, that's fair. You might not have been around front-end development long enough to remember when we had to painfully do imperative development for all of this stuff. So I'm going to give you a little bit of a preview of what it was like doing front-end development in the aughts. So this over here is jQuery around 2008, where we had to do lots of individual selectors, finding elements, manually deciding when to show or hide or append or delete. And it can be really tricky to keep things in sync. And inevitably you got off by one and then your page was like screwed for the rest of the life. You just tell everyone to refresh and it'll fix itself eventually. Then React came along in about 2013 and we could just say, this is what I'd like the page to be. No clue what it looks like right now. Don't care. This is what I want it to be. And React had your back and got everything else on the way. So how does it actually do that? Well, it's a process called reconciliation. So what it's doing is if you give it something like this in your JSX, right, that's your virtual DOM, and the actual DOM looks something like that, then it's going to go through and compare and say, okay, I need to create this loading spinner. I need to create another button. Maybe I need to add this disabled property and generate this long list of all the transformations that it has to do. And then it's going to go and execute, right? So you give it what you want it to look like. React figures out how to actually use the DOM to get there. And there's two last terms I need you to take away from this, and that's render and commit. And these are two very important phases in the React lifecycle. So render is everything involved in creating the virtual DOM, and commit is everything involved in actually creating the DOM. So this is lightning talk. I'm not going through all this. I'll send the bit.ly link out later, and you can feel free to dive in at your leisure about all this stuff. But go nuts diving in here on your own time, mapping all of the different functions for class components and functional components to where they are in the lifecycle. Okay, background, fully equipped for the next 9 minutes and 32 seconds. So quick show of hands, how many people learned something already, maybe? Ooh, oh, that's great. That's a great ratio. All right, I don't even need the next 10 minutes. You can just go on here. I'll try and go through anyway, though. Profiling 101. So for all of these, we're going to pretend we're working with this application. Lovely design. Doesn't really matter. You don't need to memorize this code. If you want to follow along with the app, there's a bit.ly link up there. But the important thing here is that there is a grid of a ton of rows and a text input. That's it. That's all you got to take away for what we're going to be profiling today. And we're going to be looking at it with two main tools. First one is the performance panel in Chrome DevTools. So this is built into any Chromium browser, Chrome, Edge, Brave, even the newfangled ones like Arc and Vivaldi and all those cool things. And this is going to let you look at the end-to-end user visible performance of any application built with anything. So React, Vue, Svelte, no framework at all. It shows you absolutely everything the browser is doing and lets you dive into exactly why things are being slow. We're also going to look at it through the React profiler, which is a very specific React tool. It's a Chrome extension, so you can install it from the store in any of those same browsers. And it's going to show you the React component render times for your entire component tree. So it's helpful for a slightly different purpose. Notice how I said render and I never said anything about commit. We'll take a deeper look at that in just a second. For now, though, let's take a look at what the performance panel looks like. So if you pop open a page. All right, sorry. Okay. So to bring it up, you can right click anywhere on a page and go down to inspect, or you can hit Command-Shift-I at any point in time. And you want to put that performance tab up at the very top. And for anything performance related, we want to really exaggerate our problems so that they're really easy to see. So we're going to hit that cog up at the top right and slow down this laptop about 20x. So it's like a really old phone from 2015. And then we're going to hit record and start doing an action. So I clicked and it took about a second. Here I'm going to type. Nothing's happening. Nothing's happening. Nothing's happening. Finally. So really, really slow. That CPU throttling did its job. And then we can finally hit stop and we get a ton of data that we're about to go through. So it's going to throw a lot of stuff at you. This whole thing is called a Chromium trace. It's basically everything that the browser is doing. There's a lot going on, so we're going to focus on just these big highlighted boxes, and that's called the main thread flame graph. I know it's a mouthful. Has anyone seen this visualization before? A few hands? Okay. How many of you, so like, you're my crew up here. So how many of you feel like you understood what it was telling you? Yeah. Okay. One for three. So the other 99% of you, let me introduce you to this lovely visualization. It's basically showing you something happening over time. So left to right, we have time since we hit the record button. And from top to bottom, we have the JavaScript call stack. So this is functions that are being executed in time as the interactions are going on. So each one of these blocks here is a user interaction that triggered a ton of JavaScript to execute. And so what we want to do is zoom in on just one of these. For the most part, you don't need to know what a call stack is. You don't need to know what most of this is telling you. We're just going to be looking for two parts of this entire graph to help us with React. So overall, this is one key press. It took about 1,000 milliseconds, full second, to handle one of our key presses. It's horrendous. You should be aiming for less than 50 milliseconds. Otherwise, your search ranking starts being impacted. If you want like 30 frames per second, kind of bare minimum, that's 30 milliseconds. So we're like, 30 times worse than we should be here. And right below that is going to be whatever function installed the event listener for this. So back in the olden days, you might have manually attached an event listener to a particular element or handled a key press. Now, mostly you're doing like on click, on change, and React. So React is the one that actually installed an event listener. So React is going to be that first function. The next like 15 lines are all going to be React internal functions. You have no clue what they are, never heard of them, don't need to know. The only thing you need to be looking for is render root sync and commit root. So this is the render phase and the commit phase that we talked about in our life cycle. Our takeaway here is that both of them are pretty slow. They're both really, really long. Both of them are way over 50 milliseconds. We got to do something about that. So if we did the same thing in the React profiler, very similar step, you get the page where you want it, you click the record button, it'll give you a graph that looks kind of like this. it's only showing you one render or one commit at a time. And if you go from left to right, you're not going completely through the JavaScript call stack. You're just going through the component trees render function. So it's showing you how long each render function took. So way over here on the right, and it's really small, but the entire thing is only showing us 500 milliseconds. But on the last page, we just saw it was a full second, right? So we're missing about half of all of the time is not accounted for when we look at it in the React profiler. And so where is all of that time going? Well, when React is rendering your code, right, that big grid is going to return a ton of JSX and say, I need you to render like 1,000 rows. And so then it's going to hand the 1,000 rows to React and say, okay, for each one of these, I got to go into the row component and render that one. And then I got to go take whatever it gives me and do another one. Take whatever it gives me, do another one. So it's going back and forth between your framework code, your code, framework code, your code. And so the extra 400 milliseconds is actually React. So your takeaway when there's a big gap between the React profiler and the performance panel should be you're asking React to do too much work, right? It's not just your code that's the problem. You're also asking the framework to do a little too much for you. So we're going to take a look at how we can try and fix that. And if this is our pseudocode here, does anyone have an idea how we could get React to do less work when we have a key press? Any theories? Yeah. Yeah, so that'd be called debouncing. His suggestion was only update after the user stops typing, not on every key press. That would definitely help the individual key press responses. We would not do anything for a couple key presses and only do it once at the end. But there's a deeper thing here, which is we're key pressing in that little input, but the grid's not really changing. Right? Like the grid's just kind of staying the same. We only need to update the text. And yet every time we have a key press, we're re-rendering the entire grid, which is really, really big. So there's an easy solution for this, which is React Memo. It's a very small intervention, about like one line of code for the most part. And once you do that, poof, whole thing goes away. We go from 1,000 milliseconds to about 10 milliseconds, even with the 20x throttling. And the render phase itself takes what, 0.4 milliseconds now. So always take a look at, do I actually need to be rendering all these things? Or can I ask the grid to not change if its props haven't changed? And with 30 seconds left, we have one more. Commit is still a problem. So when the grid does need to update, something does change, we still have a really slow commit phase. That means we're asking too much of React to manipulate the actual DOM. Does anyone see a problem with what we're doing here for the grid? How about now? Yeah, we're doing exactly what React tells us not to do, which is use the index for the key. So key is what helps that reconciliation phase know which elements React can reuse along the way. So the fix here is use some sort of stable key that is the same between all of these items so that it doesn't create and destroy all 1,000 rows when you add a single row at the top. And I know I'm a little over, so we'll quickly here. This is a lightning version of a much longer talk, but there's normally 2 more in-depth optimizations to go through. So your homework, if you're interested, is to use your newfound profiling superpowers to go find the other 2 issues in this code. And when you do, feel free to hit me up on LinkedIn, Twitter, whatever. Come chat afterwards. Thanks, everyone.
All right, introducing the next speaker, Andrew Smit. First talk ever, so make him nervous, y'all, please.
All right, we're going to talk a little bit about caching today and a really cool tool called TankStacks query. It is getting more and more popular, so this might be an intro for some of you guys, and it might be a good review for others. But before we dig in, hi, I'm Andrew. What's up? I'm a developer at Liberty Mutual, right down the road. And fun fact is I was a band director for 9 years before I switched over to tech.
And I have a 3-year-old daughter. She's the coolest person in the world. Just this one, not the emu. And this is my first technology-based talk. So I was a teacher, so I am not afraid to be embarrassed in front of a bunch of people. So here we go. Cache, what is it? All right, if you don't know what it is, the easiest way to think about it is like it's a middleman, right? So if you make an API call, the client sends a request, server does some stuff, sends it back. And our goal is to do that as little as possible, right? Like the least amount of times that we need to, all right? So what you can do is you can take that information and the response from the server and you can store it in cache on the client side. And in that way, if the same information or the same request is made, you don't have to hit the API every time, right? You can just access it from that local saved in the middle type thing that we're talking about. That obviously opens up a can of worms because a lot of different reasons, but the main thing that we're going to talk about today is like stale data. And if you don't know what that is, it's basically making sure that if you're saving some information in cache, that it's actually an accurate representation of what the server would give you. All right. And I have an example here. If you go into like your bank app and you make a deposit and then go back to the home screen, it doesn't show the money, freak out for a second, right? I actually just had this. I got new glasses and I had this error message online on warbyparker.com. That said, error, you're missing this part of your prescription. And I did this process like 4 times to the point I had to call them. And they're like, oh yeah, no, it's done. I see it. And I had to like refresh the page and it still didn't show me that it was done. So Warby Parker needs new developers, everyone, if you're looking for the job. All right. Cache, where to use it, how to use it. Today, this is like a big can of worms, so I'm gonna try to do as simple as possible, but today we're gonna talk about data fetching, right? Get your information or assets like pictures, store them in cache, and you can control how long that data is considered fresh before it's needed to be changed, dumped from cache, or if you get the requests, make sure you go actually hit the API and get it back. Something to consider is when you mutate database with CRUD actions, that's something that will then need to update the cache or invalidate the cache is a term that's being used a lot. So think of it like if they have a to-do list, you open your to-do list app, it says you have 5 things to do, then you go in and you check off that the list. Well, now if I were to hit the API fresh, it says I only have 4. You need to make sure you update that as well. All right. And the tool that we're going to use today makes that super simple. It can get really complicated really quickly, but luckily there is this awesome tool that is becoming more and more popular that we're going to talk about today, which is called TankStacks. TankStacks is an open source project. And the thing that's really cool about it is it's really effective, like right out of the box. It's not super complicated to get started. And you can go deeper and deeper as much as you want to fully customize it to your exact needs. But today we're going to talk about some very basic first steps to kind of get curious and hopefully go from there. It's really versatile with a couple different frameworks and languages. And if you learn 2 things at all, it's useQuery and usemutation. We're going to focus on useQuery today. And there's also a really good dev kit that we'll talk about too. So, and there's a little preview of look how much code can get down into 1 line. So useQuery. This is the thing I'm going to focus on a little bit today. You only need 2 things. You need a function that you're going to query the database, like get a fetch request, like you're already doing that, okay? The second thing is that you give it a key, and that key is something like it's like an identifier, it's an ID, and that way that you can very quickly grab that data or reference it when you need to invalidate it with mutations and stuff like that. And based on the stale time, either by default or you can go in there, customize it like we're going to do today to better serve your needs. Usemutation is the other one, and it's really simple, or it's really similar to useQuery. But the biggest thing here is that when you mutate, you might somehow, depending on how your app functions, need to, again, pass in those keys like invalidate, to-do list, all, or whatever it is, so that you can, when you make those CRUD actions, that you're making sure that your cache is still the most accurate information of what the server would actually give you. TankStacks has fantastic documentation. if you know little or nothing about it, that's a great place to start. Like they have really informative documentation. They have pictures, code examples. They have a YouTube series where they do like really good tutorials. And yeah, let's go ahead and get started. Okay, so you get started with these 3 CLI commands, and we'll talk about them in just a sec. Let's talk about the example that I have today. So I'm on a personal mission to use my coding skills to help me win my fantasy hockey league every year. Yeah, 2 for 3 of the last 3 years. So, and the one I didn't win, I got 2nd place. So the coding helps. This is my very simple data fetching app. These are all of the hockey teams currently in the NHL. And I'm gonna clear this real quick. You guys can focus on this network tab. If I click this, it's gonna fetch all of the lines of the teams, right? If I X out and now I go to Boston, that's a new API call. If I go to Buffalo, that's a new API call, et cetera, et cetera. This is not a crazy hard app, right? The thing I want to focus on here is that if I go back to Anaheim, I have to call the API again in its current state. If I go back to Boston, another API call. You can see these are really adding up, okay? And this is information, the cool thing about this specific API is whoever runs it is helped me win a lot of fantasy hockey leagues. But they update it very frequently. Like it's pretty cool. So for example of how I use this, Detroit, not that great of a team, right? But these 2 players are really good. This guy's not that great. So if he's playing with them, I want to pick him up on my fantasy league. And sometimes they change. So this API updates, I don't want to just grab it and then have it be there for an entire day because maybe right before the game starts, whatever. So I say all of that, not because you're interested in hockey, but because this is how I want to customize my caching is like, I want it to be considered fresh for like an hour. Probably no more, no less, because it doesn't need to update every 5 minutes, but I don't want it to be up there all day because before the game starts, I might say like, no, maybe they did switch lines, or maybe he got injured in warmups and I wasted an acquisition in my fantasy league. Okay. So here's the current state of the app. If you're like me, this is how you learned data fetching at the very beginning, right? You have your fetch request. This is just, it takes in an ID of whatever I clicked on. It builds a URL, it fetches the URL, JSON, blah, 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 etc. And then I have a use effect. So when the app loads, it triggers that fetch request, and then I save the response in local state, right? Sound familiar? It's fine. It's not great. Let's make it better, okay? So the first thing I'm gonna do, I'm gonna go to the highest level component of my application. This is made with Vite, so this is in our main.jsx. Here's those 3 command lines that I called. TankStacks query, DevTools, and then there is a ESLint plugin for TypeScript users and et cetera, et cetera. I already did that, so I'm not gonna do it yet. You import the query client and you need a provider to give it to your app. So that, there you go. Simple right out of the box. I am going to take this a little step further. And instead, I'm going to override some of those defaults. So the cache time and the stale time. Cache time is how long is this data in cache before it's just dropped. Stale time is, like I said, how fresh is it? And I set both of those to an entire day. This time is in milliseconds, so 1 second times 60 is a minute, times 60 is an hour, times 24 is a day. I'll drop that down to 1, like I talked about. I'll do the same thing here. And then you can also do this, which is a refresh interval. I'm not going to do that now if your app allows it. And that's just saying that in the background, I don't have to trigger anything. It's just refetch it, make sure it's fresh every time, okay? I'll give that a save. Now let's go back here and let's make this better. So I am going to comment out this just to reiterate. We have a function that is a fetch request, the simple fetch request, and then a trigger that's actually fires that off. And I also save that into local state. And then I pass that data down to the child. Get rid of that. Now, for the sake of time, I'm going to kind of go a little quick on this portion. I made a custom hook. If you're not familiar with custom hooks in React, the README for this GitHub repo is really well, like step by step. So if that's a little bit over your head, just stay with us for a second. But this should look familiar, right? I have my URL builder. I have my fetch, my function that actually makes that fetch request. And then here's my custom hook. I take in the ID of whatever I clicked on. I build the URL. I build my fetch function. And then here is where TankStacks does its magic. Here's my useQuery hook. And remember what I said, you only give it two things. You give it the function that you're already building no matter what, and a key. So the key that I gave it is the ID of what I clicked on in lines, because it's like the hockey lines, right? This little thing right here, retry. If I have time, I'll come back to it, but essentially that's just saying like, if it fails, it'll retry it one more time or again. And after it fails that many times, then it's going to throw the errors. Y'all still with me? Does that make sense? Cool. So here's my custom hook. Now I'm going to go, instead of getting the data passed down from the parent, I'm going to call my hook in that child component. And all I'm going to do is what was clicked on is passed into that hook. And I'm destructuring what comes back from that use query. Sorry, I got this. Okay, cool. You get a lot of information back from useQuery. The most simple one is being the data. All right. So if I have that data, let's go back to our app. Let's just give this a quick refresh. And let me just clear this so that you can see this a little bit better. There's Boston, there's Buffalo, there's Calgary. But now if I go back to Buffalo, the information is there a little bit faster. And you can see I don't have an API call because now it's reading from cache. Basically what useQuery is saying is, do you have this information? No, go fetch it. If you fetch it, save it, and save it for as much time as I declared. And if I ask for it, give it. And it's that simple, and it saves you a lot of API calls. And earlier when the guest Wi-Fi here was really slow, it was like a night and day difference for this. Now that that's up and running, I want to show you another cool thing. So another thing that is that you can destructure from this is fetching. That's just a Boolean of, am I actually in the middle of a promise right now in this API call? And I have this set up that if it is fetching, I want to show some loading information. So we can go back here. There we go. Now it's really obvious about when it's actually fetching or not. And if I go backwards, you see that it's not fetching and it's not calling the API. Pretty cool. The last thing I want to show you here, there's more, but my goal today is just to make you curious and to go figure stuff out. Because like I said, it's really effective right out of the box, right? We did this pretty quickly, all right? Is error. So I'm going to purposely mess up to Montreal. No one likes Montreal. Oh, it autocorrected. There we go. So now I expect that, oh, hold on, let me do this too. I'm also going to say retry twice. Okay. So what I suspect is that I'm going to click on Montreal. It's going to fail. It's going to try again. It's going to fail. It's going to try again. And then we're going to see an error. And I want you to follow along with the API request. Okay. So just to prove that this is still working, it's still reading from cache. We're going to call Montreal, fail. Here's a retry. Here's the second retry. And then now the error comes up, but I did not actually show you the error. Shame on me. Let's do that again. So there's Los Angeles. Here's Minnesota. Where are all the things? There we go. There we go. Cool. I know I'm out of time. Last thing, this little island guy. This is the dev tool that we passed in. You can go in here and now you can actually take a look at all of the fetches that you have currently in cache. It's organized with what's fresh, what is currently fetching, what would be considered stale based on what we put in. And if you have some really complicated stuff, you can go in and actually see the structure of the data that came back. Okay. I'm gonna share the slides with you guys and the GitHub repo. The GitHub repo, if you were to clone it right now, is exactly how I started, where it's that like old kind of dated, not super optimized version. And the README is a walkthrough of how to get this to the state that we're in currently right now. So thank you guys so much. And I hope you guys are curious about learning more. Thanks.
There's that. Okay. All right, y'all. We're good. All right, so a couple things. Number one, this is a 45-minute talk that we're cutting down to 15 minutes, so it should be great and it should be flawless. The title of this talk is TypeScript in your code base. They deserve each other. The take on this is going to be a little different than your average TypeScript talk. Just out of curiosity, how many people, show of hands, love TypeScript? Okay. Hands down. How many people are wrong in their opinion? Oh, you're, as long as you know. So I'll tell you about TypeScript. I use TypeScript for quite a few years now, previously with Angular, now with React. And I've always worked on TypeScript from the standpoint of we're creating a new application utilizing it. So we're always building it from the ground up. My last organization was AutoZone, and AutoZone was the first time I walked into a very massive repo that already had TypeScript implemented within it throughout the entire place. Now, was it always perfect? No, a lot of people used any and this and that, kind of cutting shortcuts to make it work. But the reality was, of all my experiences ever working in organizations anywhere previously, this was the fastest onboarding time I have ever personally experienced. And one thing that I started realizing is TypeScript ended up making a lot of the code a lot more readable, at least to me. But on top of that, I started understanding really early on how things were interacting with each other, what was expected. I was getting very valuable errors that were kind of explaining a lot to me within that process. That was extremely valuable. And I think a lot of people avoid TypeScript not knowing why, or thinking the learning curve is too hard, et cetera, et cetera. But instead of saying my opinion is TypeScript is phenomenal, I want to approach this talk more from the standpoint of let's let data decide whether or not we should start adopting this within our practice, within our organizations and our teams. All right, data. Let's go for this. Here are the facts. TypeScript is the 4th most popular language on GitHub by the number of contributors, demonstrating its widespread use in open source projects. This is a very big jump from where it was several years ago. Second fact, the number of TypeScript-related packages and their downloads has been increasing, indicating a growing ecosystem and adoption in the JavaScript community. I think several surveys as of recent have also supported this with the adoption rates. TypeScript is the 2nd most loved language with 73.1% of developers, according to Stack Overflow survey of 2023. The new survey just came out. I should update this, but this just came out literally the other day. On December, this was one I really found really interesting. December 25th of 2022, there were 19,131,979 NPM downloads for TypeScript. On June 2nd of this year, 54,249,484. That big difference is not just going to be hobby developers picking something up at that point. This is enterprise level organizations adopting this at a very large scale and implementing it within their code bases. Especially if you're a developer in today's marketplace, this is something you need to be paying attention to if you're touching anywhere close to the front end, or if your goal is to be a full stack developer. TypeScript rise in popularity. 2023, TypeScript overtook Java for the first time as the 3rd most popular language across open source projects on GitHub, with 37% of its growth of its user base. That's a huge number. Now, using the data again, in 2020, this side right here, TypeScript was all the way at the bottom of the 1, 2, 3, 4, 5, 6, 7, 8th position for professional developers utilizing it within their tech stacks or knowing about it. In 2024, with the overall number of respondents even growing almost 50%, it is in the top 5. TypeScript may end up becoming the preference for enterprise level organizations and companies. Might be something you should keep on your radar in case you haven't thought about it. According to data from Stack Overflow surveys, the percentage of professional developers using TypeScript increased approximately 54.59%. Yeah, I know how to use a calculator. From 2020 to 2023, that's 3 years. Also jumping up higher in the rankings. It's something to now start paying attention to. Now, I know what you're thinking. Sometimes when I look at TypeScript, the code is confusing me. It's frustrating. To be honest, if you really read the errors, they're very detailed. There's a lot of extensions now that make reading those errors pretty easy as well. We're going to kind of go over that a little bit. All right, why is TypeScript worth learning and using? To be honest, the biggest immediate advantages to me are code readability and catching errors at compile time instead of runtime. For some beginners, they may be confused what this actually means. And so we're going to kind of go over this for you. So remember 2 big things: catching errors and readability. That should be top of mind for you as we're going through this. Compile time is when the computer translates your written code into a format it can execute. It happens before the program runs. Runtime is when your program is actively running, everything is going on and it's performing tasks. It's a very big distinction. So imagine you're baking a cake and following that's a little too hard of a laugh right there. All right. Imagine you're baking a cake and following a recipe. Compile time would be checking the recipe, ingredients, and instructions before you start baking it. Runtime is when you are actually mixing the ingredients and baking the cake. That's a very big distinction. Catching that error before you mix everything together would be a huge time savings, because if everything's already mixed together, you got to throw that out, start a new batch, you got to go through all this stuff. Catching that early on is a very big distinction. Now that we understand the difference, you'll see that TypeScript errors in your editor right away. Here's an example to illustrate this. Oh yeah, the example is here. Hold on one second. Yeah. So here we can kind of go through this. Yeah, you can see that. All right. So here we're getting an error right away. You see those red squiggly lines. Here we have a function, very basic function, where we're basically saying we're calculating our total. We have a price with the type of a number that we're expecting. We have the tax as a number, and we're saying that the output would be a number, and we're returning price plus tax, even though we're not explicitly putting a type here for that return value. Let results calculate the total. We have a numeric value of 5 and a string value of 10. Since we've already dictated at the top that we're expecting a number type, it catches that error for us right away. Now, in basic JavaScript, this would, basically put this through here, and we'd see 510 versus, the total of 15. So that right there, I think, is a big, big distinction on how we're utilizing this. It's very easy to read. You know what the values are expected, and if someone tries to pass in the wrong value, you are covered. And the reason why I'm saying this in particular is not just you writing perfect code, right? Every software developer, I remember having a very large conversation with a CTO on LinkedIn who was trying to debate in a very healthy way. Like, I'm very big on open communication, debating. I love challenging ideas. And we basically were talking about the merits of TypeScript. And he said, Danny, everyone has tried to tell me TypeScript is the best, TypeScript is this, TypeScript is that, la da da. There's no reason for this. He's like, if I just write my code right the first time, if I put the test in there, we're good. I said, you're right. If you do that, you're covered. What about the junior that we hire next week? They may not write it perfectly. And so by having those types there, you're covering yourself for all developers that are coming in contact with your code, besides you, aka, I guess, the perfect dev in his situation, right? So think about that. That conversation is still on LinkedIn, by the way. I didn't delete these comments. I left them up there. So if you're curious, you can probably find it. So as I always do in all my talks, I add one very, very important thing that will help you as a developer. Terrible jokes. So why are TypeScript developers always in shape? Because they do a certain type of lifting. Yes, it's painful, I know. All right. So kind of going over what I said before, as you can see with TypeScript, you get that specific error here. So argument of type string is not assignable to whatever it says behind my head. Okay, and so that's kind of what you need to be thinking about. The errors that you get are no longer obscure, where, for example, in console, you may get exactly what you're wanting, or you may get something obscure. Here, it's very detailed. You know exactly what's expected. The problem is some developers, especially newer in TypeScript, they get intimidated by said errors. It's something you should be not so intimidated by. So here I'm giving an example to kind of showcase this one step further. We have a function here, get user data. We're using a example from AppWrite, by the way, sponsor for our meetup and all that good stuff. And I have an application that we're going to go over real quickly to showcase this. But let's say we have some data that we're passing in, we're fetching, and we're trying to get it. And so we're passing the user data of user ID for number 1. Well, when you do that, where TypeScript ensures the data has the name property of type string in this example here, right? If the name is missing or if the wrong type, TypeScript will throw a compile time error. So we'll catch it right away, and the error message will show property of name is missing in type, age, number, but required in the data, right? So here we have our name as string, but we're passing in a numeric value for the user ID. So it's getting caught up there. More important information, why did the TypeScript developer cry after buying a house? Because his bank account was showing null. Yeah, I recently went through that actually. All right. Yeah, it hurt. All right. So using this example again, the way that you're going to end up doing this is you're going to have interfaces, and we're going to be utilizing interfaces to pass in information. So an example of this could be you have an interface of user with a name of string and an age of number. So if you pass in Alice and then age, we would get that value. But to take this a step further, you can add interfaces inside of other interfaces. So the interface of address, let's say, we have a street address, a city, a zip code, and then we have our user. So we have our user with the name of string and an age, and then we pass in that interface of address, and we can get all those types there. So from a reusability standpoint, it can help you out, especially not having to constantly retype the same items, for example, multiple users or different scenarios. So now if I were to enter here, the user of Bob, age 30, address, and then inside that doing an object scenario where we have street, city, and zip, we would be valid there. So now let me kind of X this out here a little bit, and I'll kind of show what we're working with. If I can get this view out of there, perfect. So I'm going to bring this here, and this is going to be a little challenging for everybody to see, but this should work. Actually, you know what? Let me bring this back here and let me duplicate my screen instead of extending it. That'll probably be the easiest scenario now that I think about it. Displays. And then from here, we will display settings. Mirror. So do we both see the same thing now? We do. Perfect. Okay. So this will work. All right. And let me hide these meeting controls. Hide this. All right. So let's see. Do we see everything perfectly? Perfect. So we're using AppWrite for this application, and I'll kind of go over that in a second. We have an application here that I developed called DSD Fitness. It's basically a calorie tracking application where you can enter, let's say, the meals for the day. You can enter your calories and so on and so forth. You could take this a step further if you wanted to implement pagination, where you can have dates and store items like that. If we go through our database here, you can see that I have 5 items here, nothing, major or crazy. It's follows SQL standards. So I'll add an item here, since we're at a meetup, we're eating some pizza. We'll say 300 calories per slice. I probably ate 4,200 calories, but we'll keep it minimal now for, let's say, 420. And so you can see the calories update there. And if we check the database and we refresh, we see it there. Y'all now have proof that I do know how to code after all. And so we can kind of go through this ever so slightly. So the way that this is working, let's see here. Let's go through the first step where my notes are, and I can't really see my screen now. Okay, here. So let's go through our app TSX file. So what we're doing as we go through this, to kind of give you all an idea, we have our interface of a document. The document is basically the files that you retrieve from AppWrite itself. We have a string, ID of string, and it uses a $sign, and then created that for the dates. So if we wanted to filter these by date, we could utilize that through that created app. We have food of a string, calories of number. And then here we have our collection ID, and whatever reason this is not scrolling. Why is it not scrolling? What the? Did everything freeze? Oh no. Yeah, the internet didn't want y'all having proof that I know how to code. Okay, here we go. I was worried for a second. All right, and so we have our collection ID, which follows SQL standards. So collection ID is basically an ID, a database ID, updated that, and we'll kind of go through this. So the list documents response interface describes the structure of the response when fetching documents from the database itself. It includes the total number. Maybe I need to close the server because it just froze up again. All right, let's just go close the server. Maybe that'll help. So the list document response interface describes the structure of the response when fetching documents from the database itself. It includes the total number of documents and an array of document objects. All right, so we have our interface of list documents response, the total being the number, and documents being an array of documents. Here, we're passing in a couple things. We are using a modal state and a set modal state. So when we have that modal where you enter the food, that will pop up, and we're using state closed for the modal state there. We have our calories that we're setting, food, calories, etc. We have our daily goal, say 2,000, just for argument's sake. The fetch and display data function fetches data from AppWrite database and updates the state with the fetch data itself. So we're using a database, listening to documents, we're passing in the document IDs there. Then we're getting our response. From that response, we're setting our calories. I'm trying to go through this fast, but this thing is freezing up on me. Dang it. Yeah, I don't know why it keeps freezing up. I'm trying to scroll. Let me just get to like a page that will work, I guess. So here we're using our calorie table, just passing in the props of calories. And you can see our modal here. We have our is open being a Boolean. On close, it's a function for voiding it. On save, we're passing in another function with 2 types and then voiding that. And we can pass those in through props through the modal itself and utilize them throughout the application. One last thing that I really want to hit on, if it can let me get there, whoops, is, let's see, I wanted to hit on one thing, this. So this is slightly more advanced, but it's valuable. So we have an interface of our modal being closed, and we have an interface of our modal being open. And so here we have our state, which is actually a string saying open versus the state being closed, and we're passing a couple of things. This is actually called a discriminated union. So our export type of modal state, we have our modal closed, we have a pipe, which is the straight up and line bar, if you're not familiar with that term, and the modal open. Discriminated union is a pattern in TypeScript that combines union types with discriminant properties to enable type-safe differentiation between different variants of the union. It is particularly useful for modeling situations where an entity can be one of several distinct states, each with different properties. Both modal closed and both modal closed and modal open interfaces have common properties, which are state, which acts as the discriminant, meaning that can be a changed value. So in this case, the value of state is a string literal that uniquely identifies the variant closed for modal closed and open for open. So based on what type comes through, that's going to be the interface that it showcases at that time. Modal state is the union type that can be either modal closed or modal open. And let me just do this last one here. Thanks for your presentation. Thanks for attending my talk. There was a different slide there. I don't know what I did to it, but I don't have time. I know that was amazing. Please hold your applause. And from there, one thing that we do at the end of all meetups, I know we're on time, is we take one big group photo together. So everyone.